This is a continuation of the test for review questions. We're picking up with question 13, and then I've added a supplemental question at the end of the review because it's one that I noted was on the actual test, but you hadn't really seen an example like it, so I wanted to share that with you. So question 13 says, write the following expression as a single logarithm. And I noticed that initially we have 1, 2, 3 terms, and we want to rewrite that using the properties of logarithms to rewrite it. And so the first thing I notice is that I have the numbers out in front of the logarithms, and the power rule tells me that that's going to go back up and become an exponent. So I have the natural log of x squared minus the natural log of y minus 4 to the third minus the natural log of z plus 2. Then we're going to work left to right, and as you work left to right, you do combine them together using the appropriate property. So looking at the first two, ln of x squared minus ln of y minus 4 to the third, they're being subtracted. Subtraction is rewritten as division. So we would have the natural log of x squared divided by y minus 4 to the third minus the natural log of z plus 2. Again, working left to right, then I'm going to, again, I have subtraction, so it's going to become division. So I have the natural log of x squared over y minus 4 cubed, and that whole thing is divided by z plus 2. Now remember that z plus 2 is over 1, so we have a division. We rewrite the division as a multiplication problem, so this becomes the natural log of x squared over y minus 4 cubed times, remember flip and multiply, so it becomes 1 over z plus 2, and then we multiply the numerators together and multiply the denominators together, and we end up with the natural log of x squared divided by y minus 4 cubed times z plus 2. And there's your answer. All right, question 14 says, write log base 7 of 13 equals y in exponential form. Okay, so you have a logarithm, you're going to rewrite it as exponential. We would write 7 to the y equals 13. Kind of generically, you would have the base of your exponential and the base of your log are the same, raised to your answer, whatever's after the equal sign, and that's going to equal your argument. Okay, now you may not remember, so let me kind of point out the things here on the actual problem. The 7 is the base. The 13 is your argument. And obviously y is your answer. Okay. Now that finishes the actual review, but I want us to take a look at another question that's kind of difficult that they kind of throw at you on the actual test. And it looks daunting because it's a really long question, but they have to explain the formula to you. It says the Richter scale gives a mathematical model for the magnitude of an earthquake in terms of the ratio of the amplitude of an earthquake wave, also known as the intensity of an earthquake, to the amplitude of the smallest detectable wave. If we denote the magnitude of the earthquake by R, the intensity, also known as the amplitude of the earthquake wave, by A, and the amplitude of the smallest detectable wave by S, then the model, and they give you the formula. And then they say, in 1906, San Francisco felt the impact of an earthquake with a magnitude of 7.8. Many pundits claim that the worst is yet to come, with an earthquake 936,050 times as intense as the 1906 earthquake, ready to hit San Francisco. If the pundits' ability to predict such earthquakes were correct, what would be the magnitude of their claimed earthquake, and round your answer to the nearest tenth? Now, this is really a two-step problem, because they tell us the magnitude of the 1906, and then they start talking about the amplitude of the one that they're predicting about the worst is yet to come. So the first thing we're going to do is actually we're going to solve for A. We need to kind of know the idea of the amplitude of the earthquake in 1906. So to do that, I'm going to substitute into the formula. Okay, so I know I had a 7.8 magnitude earthquake, and it had an unknown amplitude and an unknown smallest wave, because I don't know those two things. So I have this equation. And then I'm ultimately trying to solve for A. So I need to undo the log. So we're going to do 10, because it's a log, so we have the understood base 10. So I do 10 to the 7.8 equals 10 to the log of A divided by S. Okay, so we have 10 to the 7.8 equals A divided by S, because the base 10 and the log will cancel each other off, their inverses. And remember, I'm trying to solve for A. So I'm going to multiply both sides by S. So the amplitude of the smallest wave times 10 to the 7.8 power corresponds to the amplitude of the earthquake. Now, they claim, okay, so here's our claim. Our claim is that the earthquake to come is going to be 936,050 times as intense, which is A. But we just determined that A is S times 10 to the 7.8. So if we substitute this in, we're trying to find R of this predicted earthquake. So we would have log of 936,050 times 10 to the 7.8 times S, all divided by S. Now, what that does for me is, if you'll notice, then the S's actually divide out. The S in the denominator and the S in the numerator divide out, so that I have R equals the log of 936,050 times 10 to the 7.8 power. And guys, at that point, I'm definitely getting out my calculator, okay, and I'm going to type it in. So I would have the log of 936,050 times 10 raised to the 7.8 power.
Hello, please leave a message after the tone.
Okay. And we get 13.8, because it said round to the nearest tenth. So when you get it in a calculator, you get 13.8. Okay, you may definitely want to write down this example. You may not have the same numbers, but at least you have an idea now of how to work the problem. You have to solve for the amplitude first, then, using the claim, set up the formula to determine the magnitude of the predicted earthquake.